Okay, go ahead and take out your geobooks. Let's get started with video number 24. This video is on circles. Okay, let's get started. Okay, go ahead and open up your geobooks to the vocab section. Our first word is minor and major arcs. The definition says, given 2 points on a circle, the minor arc is the shortest arc linking them, and the major arc is the longest. So if we look at our picture over here on the right side, we have our circle. We have our 2 points that are on the circle. Our minor arc would be the arc of the shortest arc, which would be BC, and our major arc would be all of this red arc over here. And the name of this arc would be arc BDC because we have to use another point that is part of that red arc. Okay, if we want to call it, we cannot call it arc BC, just go from B all the way around to C, because if you say arc BC, then you're talking about this little arc from B to C, the shortest arc. Okay, so again, remember, for a major arc, you have to use 3 letters, okay, 3 points that are on that arc, so B, D, C. Okay, our next vocab word is intercepted arc. The definition says that an intercepted arc is created when segments intersect a part of the circle. If you look at our picture here on the right side, all of these are examples of intercepted arcs. These are pieces of the circle, and the arcs are the outer part of the circle here in the red. So that's an intercepted arc, intercepted arc, intercepted arc. Another way to think about intercepted arc is to think of pizza over here. Okay, if you think of the crust of a slice of pizza, for example, the intercepted arc would be that crust right here, where you can see that the segments intersect a part of the circle, and that crust would be your intercepted arc. Okay, our next vocab word is central angle, and this is an angle with vertex located at the circle center and endpoints located on a circle circumference. So if we look at our picture over here, our central angle is this angle here, where the vertex is at the center of the circle, and you have your 2 endpoints located on the circumference of the circle. Okay, and if you look over here on the bottom, we have the relationship between the central angle and the intercepted arc. Remember, this is your central angle, right in the middle at the center, and this is your intercepted arc. And the relationship between them is that the measure of the central angle is equal to the measure of the intercepted arc. So they're exactly the same. So let's say this central angle was 40 degrees, then the intercepted arc would also be 40 degrees. If this was 50 degrees, then this would be 50, 60, this would be 60, and so on and so forth. Okay, our next vocab word is inscribed angle, and this is an angle that is formed by 2 chords in a circle which have a common endpoint. Okay, if you look at the picture over here on the right side, here is our inscribed angle, this blue angle, and you can see that you have your 2 chords over here, and they meet at a common point, and this will be the vertex of our inscribed angle. Okay, the inscribed angle, it also creates an intercepted arc. Remember, we talked about this. We had the example of the slice of pizza. Okay, this is the crust of your slice of pizza. Kind of, not really, because it's not really a slice from the middle, but it still creates an intercepted arc. Okay, and if we look over here at the bottom, we can see the relationship between the inscribed angle and the intercepted arc. Okay, in this case, it kind of changes a little bit from our previous slide. Remember, in the previous slide, the central angle and the intercepted arc, they were exactly the same measure. Here, the measure of the inscribed angle is equal to half of the intercepted arc. Okay, so the inscribed angle is half the measure of the intercepted arc. So let's say this was 80 degrees, then this would be 40 degrees. If this was 60 degrees, then this would be 30. So now we have to take half of it. Or if they give me the inside, if they give me the inscribed angle, then I would have to multiply by 2 to give me the measure of the intercepted arc, okay? Okay, so we have 4 examples for this video, and they're actually going to go pretty fast because it doesn't really require a lot of work. Okay, so let's go ahead and get started with our first problem. This first problem is asking us to find the measure of arc AB. So over here on the right side, I'm going to put measure of arc AB is equal to something, and this is what we're trying to find. Okay, so if we look at our picture, we can see that we have 2 points that are on the circle, and we have that center point. You can see that that O point is in the middle or at the center of the circle. So that means that this angle here is the central angle. And if we go back and look at your notes, you guys can see that the relationship between a central angle and its intercepted arc is that they are equal to each other. And so remember, if they're equal to each other, that means that they have to be exactly the same. So our answer would be the measure of arc AB is 84 degrees. And that's it. Okay, this next problem is asking us to find the measurement of angle ABC. So angle ABC would be from A to B to C. Remember that your angle, your mark goes at that middle angle, which is B. So I'm going to put my little arc over here at angle B. Okay, so they're asking us to find this measurement. Okay, so remember that we have 2 choices. We have a central angle and we have an inscribed angle. Okay, in this case, does it look like our angle is starting from the center of our circle? Well, no, it doesn't, right? Okay, it's starting from it's over here at a point around the circumference of the circle. So this right here is an inscribed angle. And remember that the relationship between an inscribed angle and its intercepted arc is that the inscribed angle is half of the intercepted arc. So we are going to take half of 104. Okay, and if we divide 104 by 2, we get 52. Okay, so measurement of angle ABC is equal to 52 degrees. Okay, our next example is asking us to find the measurement of angle CAB. Angle CAB is over here. Again, if we want to mark that angle, remember that it's always that middle letter that you want to mark. Okay, so middle letter is A, so I'm going to mark my angle at angle A, at letter A. Okay, so we're trying to find this angle here. We want to know what the measurement is. Okay, so by looking at the picture, we can see that we have a central angle, right? We can see that angle BDC is a central angle. And again, we know that a central angle and its intercepted arc have to be exactly the same. So then BC, arc BC is going to be 108 degrees. So we're going to use this information to help us find the measurement of angle CAB. Okay, if you look at that angle CAB, what kind of angle does it look like? Does it look like a central angle or does it look like an inscribed angle? Okay, remember a central angle has to start from the middle, and we already decided that this angle here, BDC, is our central angle. So that means that angle CAB is going to be our inscribed angle. Okay, and we know that the relationship between our inscribed angle and our intercepted arc is that the inscribed angle is what? What is it? You guys know it. Okay, that the inscribed angle is half the measure of the intercepted arc. Okay, so we're going to take half of 108. And half of 108 is 54. So that means that this little angle in here is going to be 54 degrees. And we're going to write that as measurement of angle CAB is equal to 54 degrees. Okay, so our last example is asking us to find the measurement of angle C, and they tell us that arc BC is 80 degrees. Okay, so let's go ahead and mark 80 degrees on our picture. Here is BC. Here's BC, arc BC. So right here we're going to write 80 degrees. We know that this measurement is 80 degrees. Okay. Now for this problem we're going to do something that we kind of didn't really talk about in this video, but we have talked about it in class. Okay. Let's talk about how many degrees are all around the circle. Okay, so if you're thinking 360, then you are correct. Okay, remember we have talked about the circle, and all around the circle it is 360 degrees. Now, we're not going to use the entire circle for this problem. We're going to use half of the circle. So what would be the degree measurement for half of the circle? Okay, well, half of the circle, so half of 360, if you're thinking 180, then you're correct. Okay, so that means that from here, let me make this bigger, okay, this half of the circle, this is 180 degrees. So that arc right there is 180. This arc that we started with is 80 degrees. So how would I find this part, or this arc from AB, arc AB? Okay, well, if you're thinking that you're going to subtract, then you are correct, because we have one piece that is 80. Oops. We have one piece that is 80, and we have this green piece over here, and we know that the entire thing has to be 180. So we're going to take 180 minus 80, and that's going to give us 100. So this arc, this green arc, is 100 degrees. Arc AB is 100 degrees. Okay, so why did I want to do that? Well, because if you look at your picture, if I highlight this part, we want to look for angle C. And angle C is made by those two segments, right? AC and then BC. Here's angle C. And that's what I'm looking for. Okay, well, this angle, angle C, is an inscribed angle. It's not a central angle because the vertex is not in the center. The vertex is not here. The vertex is over here on the outside, on the outer part of the circle. So this makes this an inscribed angle. And, well, what is the relationship between an inscribed angle and its intercepted arc? Well, we know that it is, the inscribed angle is half of the intercepted arc. Okay, so forget about everything else on the picture. Let's just worry about the inscribed angle and then this green arc, AB. Okay, we know that it is half of the intercepted arc, so we're going to take 100 divided by 2, and we get 50. Okay, so we know that angle C, measurement of angle C, is 50 degrees. Okay?